So continuing with functions and relations, it's important to understand what they look like when you start graphing and working with tables and stuff like that. So we're going to first talk about a mapping diagram. And what a mapping diagram is, it shows how a function, and what a mapping diagram does is it shows how relations or functions assigns inputs and outputs. You've probably seen mappings before. They often are, or they're always two circles with arrows going in between them. That's what a mapping looks like. So the left side always lists the inputs, and the right side always lists the outputs, and the arrows show which outputs connect to which inputs. Shows us how they're connected. So the idea of mapping is connecting them together, is the connecting the inputs and outputs. The great thing about mapping is that both functions and relations can have mappings. And every single arrow that you have drawn represents one ordered pair. Remember, ordered pairs are how we graph, and they're going to be parentheses with a comma with an X and a Y. So a function is a mapping that assigns one and only one output value to each input, and a relation is a mapping that assigns one or more output values to each input value. So, as we learned before, it is true that a function is a special type of relation. But a relation is not a special type of function. So we're supposed to create two mapping diagrams that show, the first of which shows that it is also a function. So if it's a function, that means for every input, I get exactly one output. The way that's going to look in a mapping is that on this side, there's only going to be one arrow from each number. So 1 could map to 2, 2 could map to 4, 3 could map to 1, and 4 could map to 3. So ordered pairwise, this would be the ordered pairs 1, 2, 2, 4, 3, 1, and 4, 3. But a relation that's not a function means that one of these numbers is going to have two arrows. So the example I've given you right now, 1, 1 and 1, 2, that because this 1 is duplicated, that makes it not a function. Because there's two arrows here, that automatically makes this not a function. It doesn't matter what everything else goes to. 3 could go to 3. So that would be the ordered pair 3, 3. 2 could go to 4. And 4 could go to 3 as well. We'll say that. But simply because this right here has two arrows coming from it, and there's two 1s listed in our table, this makes it not a function. Not a function. So it is a relation though. So because a function never assigns two output values to a single input value, its graph never has two different points with the same x coordinate. So there's this test that we can use to determine whether functions or whether graphs are functions or not. And this test is called the vertical line test. The vertical line test says that if you draw a vertical line, remember vertical is up and down, so it's a line that looks like this. And if that line touches once, it's a function. If it touches more than once, it's not a function. This is one of those things that is actually easier to see in action. So looking at these graphs, it asks us if they're a function. Well, to determine that, we draw a vertical line. And we ask ourselves, did it touch once or twice? Or 3 times or 4 times? Well, this line touched twice, so that makes this not a function. The next graph, if I draw a vertical line here, it touches 1, 2 times. That makes it not a function. This third graph, if I draw a vertical line, it only touches once, so that's good. If I draw it here, it only touches once. If I draw it here, it only touches once. No matter where I draw that vertical line, it's only ever going to touch the graph one time. And so that makes this a function. So the first two were not functions, but the third one was a function. So here we have another graph, so we're supposed to determine if this is a function or not. Well, if I draw a line here, one time, one time, one time. It's not going to matter where I draw a vertical line because no matter what, it's only going to touch it once, so that would make this a function. So if you didn't have a graph, let's just say they gave you an equation and you wanted to know if it was a function or a relation, well, it's really easy to figure it out. If it's a function, then it will just have y. Okay? If it's not a function, that means that it will have y squared or y cubed or something else where y has an exponent with it. So we're supposed to figure out if these are functions, so all we have to do is look at the y value. If it's just y, we're good to go, so this would be a function. But if we look at the next one, this one has y squared, so that makes it not a function. The third one, here's our y, and it's just y, so that would make it a function. Our fourth one, this one's a little bit tricky because see, it just has y here, but there's this squared out here that goes along with that, so that's going to make it not a function. Our fourth one just has y, so that's going to make it a function. The fifth one has y cubed, so that makes it not a function. The next one has y squared, so it's not a function. And the last one just has y, so yes, it would be a function. So we can also use mappings to help us answer questions. So it says, refer to the mapping diagram to answer the function age of student. So for question 1, it says, according to the mapping, what is age parentheses Peter? Remember, we can read this as age of Peter. Well, this is really easy because all we have to do is go up here, find Peter, see what he maps to. He maps to 16, so 16 is our answer. So for number 3, it wants the age of Angela. All we have to do is look at Angela. She maps to 18, so that would be the answer, 18. I want to ask you a question. Is this a function? In order to figure out if it's a function, all we have to do is look at the right-hand side. We don't even have to look at this left side over here, so I'm even going to color it out. All that matters is that every single one of these names has one arrow going from it, or one line. And that is true, so yes, this would be a function. So it is important to note, because there tends to be some confusion on this. It is okay that 16 has 2 arrows. That is okay. That does not, this side does not affect the function. It can have two outputs, can have the same input, but one input cannot have 2 outputs. All right, number 5. We have to figure out if this is a function or not. So remember, all we have to look at to determine if this is a function is the left-hand side. So again, I'm going to mark out the right-hand side. We're not even going to pay attention to it. It does not matter. So if this is a function, then every single one of these should have exactly one line coming from it. 0 has 1, 1 has 1, 2 has 1, 3 has 2, so this would not be a function because of this right there. Number 7 is this graph. It wants to know if it's a function. Well, to determine if a graph is a function, we try the vertical line test. So I'm going to draw vertical lines. My line should only touch the graph once. As long as it only touches the graph one time, we're good. Every line touched it once, so this would be a function. And lastly, we have number 9. We want to know if this is a function, so we do the vertical line test. Well, this line touched the graph twice, so this would not be a function. But remember, it is still a relation. And number 7 is also a relation. Because if it's a function, it's also a relation. They always work together.